Hello, everyone, and welcome to our webinar. Today we have a really exciting topic, using sustainability to repair and maintain existing concrete and masonry buildings and infrastructure. Our host is Brittany Storm. Brittany is the Sustainability Manager for the MAPEI Corporation. Her background as a sustainable building consultant and background in construction allow her to speak to audiences about both the big picture and technical aspects of a project. Brittany is a lead fellow with the BDNC and IDNC specialties, as well as a WELL AP and Fitwell ambassador. In addition, she is active on many sustainability committees. Just as a little housekeeping, if you have any questions, please feel free to drop them in the question box in the upper right-hand corner, and we'll be sure to answer them at the end of the presentation. All right, Brittany, without further ado.
Thanks, Brianna. Good afternoon, good morning, wherever you're tuning in from. Looking forward to discussing sustainability as it relates to existing concrete buildings and infrastructure today. Today's learning objectives, I'll give a brief history on sustainability in the construction industry, talking about promoting sustainability and resiliency and what's needed for ongoing maintenance to improve existing buildings. How you can start to develop long-term preventative maintenance plans to avoid deterioration or further deterioration, and then creating a repair process that would help reduce the environmental impacts of your project, existing building projects. So before we get into the guts of the presentation, I like to share this slide. It's MAPEI's approach to sustainability is the 3 P's of MAPEI, which are people, planet, and products. Our processes focus on sustaining the environment for today and tomorrow. MAPEI is committed to providing the industry's best and most innovative solutions that are achieved through the consistent practice of following sustainability principles. And this requires a sense of responsibility and the ability to make concrete choices to supply designers, contractors, and customers with long-lasting products that are not only reliable, but they're also durable and have the lowest impact possible on our health and the environment. And every product line offers different sustainable attributes and certifications. I'm happy to talk to you offline about all of MAPEI's sustainability efforts. So without further ado, I'll get into the reason you're all here today. So sustainability is often referred to as the ability to maintain or support a process continuously over time. Today, as we seek ways of meeting our own development needs, there is an increasing threat of climate change. Concrete efforts, pun intended, must be made to ensure development today does not negatively impact future generations. When it comes to the built environment, sustainability is not a new term. Rather, the term sustainability is ever expanding. Sustainability means different things to different people. Sustainability represents the process of designing, constructing, and operating the building in a way that reduces health and environmental impacts. So the definition that we saw in the last slide was defined by the UN, United Nations Brundtland Commission in 1987, and that was defined shortly after the major nuclear plant catastrophe in Chernobyl. And then fast forward 20 years to another natural disaster, Hurricane Katrina. There were additional sustainable building characteristics added to the sustainability overall definition, which were resiliency and durability. Resiliency represents the ability for something like a building to adapt after a shock. Durability, similar to sustainability, has many approaches. The durability of the building itself, the durability of the materials, the functionality of aesthetics. So the more durable a building is, or the more it lasts, the less impact it has on the environment. And a key component of sustainability in the built environment is resiliency and durability. Concrete has been around in various forms for thousands of years. In the modern world, concrete defines much of our built environment. Concrete is the most widely used construction material in the world. It's widely used for its durability, versatility, strength, and ultimately sustainable construction material. Much of our historical built environment is still standing today because it was built using concrete and masonry construction, or both. One of the first forms of concrete used that still exists today can be found in the pyramids in Egypt, which were built around 3000 BC. Both the Colosseum and the Pantheon are excellent examples of the longevity and adaptability of concrete. And the Ingalls building on the far right there in Cincinnati was built in 1903. It's the world's first reinforced concrete high-rise building. So with adherence to best practices, concrete and masonry stand above many other construction materials in their ability to resist insect damage, fire, impact, abrasion, moisture exposure, and other factors, provided that these structures are systematically maintained. And to make things more tangible, and to confirm the importance of sustainability in concrete repair and maintenance, the cement and concrete industry contributes to $100 billion to the US economy every year. According to the MIT Concrete Sustainability Hub, the US is projected to add 121 billion square feet of buildings by 2050. And this does not include expanding and rehabbing existing infrastructure. The Portland Cement Association estimates US cement consumption will reach 143 million metric tons by 2040. And moreover, the construction industry is responsible for 50% of raw materials that are used. It constitutes about 40% of total energy consumed. Construction and demolition activities represent 50% of all waste generated. And the construction industry accounts for approximately 40% of global carbon emissions. 25 years from now, 80% of the buildings we use today will still be in use. So that means it's important for us to properly deal with existing buildings and infrastructure in order to provide, by repairing and maintaining, a new life cycle to existing construction for future generations. Proactive protection, maintenance, and repairs offer the ultimate inherent sustainable advantages to building new. The thoughtful extension of life of existing structures through careful repair and a commitment to long-term maintenance is a responsible way to reduce our impact on the environment. Because of their durability and resiliency, concrete and masonry are often ignored until signs of deterioration are evident. The most effective sustainable strategies for concrete and masonry structures is to avoid the need for repairs altogether. Sustainable repair and maintenance, again, are vital for minimizing the environmental impacts. For instance, addressing efflorescence involves cleaning and sealing with saline-based water repellent products like Planiseal WR or Planiseal WR40. These transparent sealers provide resistance to water, dirt, and chlorides. Cracking can be managed with epoxy injection resins such as EpoJet or EpoJet LV. Moisture penetration solutions, depending on the source. Planiseal 88, which is a cement-based waterproofing and surface preparation coating, would be suitable for positive and negative side applications. Planiseal CR1 is a single component, 100% solids, cold fluid applied structural waterproofing membrane that's ideal for the positive side. Interior delaminated areas can be repaired using appropriate toppings like Ultratop, which is a self-leveling, self-curing, sealed or polished topping that is specially formulated for fast-track resurfacing of horizontal wear surfaces. And then for exterior areas that are scaled, they can be resurfaced with a product called Concrete Renew. It's a one-component polymer modified cementitious material. Corroded reinforcements require rebar repair, removal of chloride contaminated concrete, and the use of MAPEIUSA 1K, which is a corrosion inhibiting coating for reinforcing steel. And the last two that we have here is Planning Bond 3C, which is a 3-component cementitious corrosion inhibitor and bonding agent. And there's also MAPA Shield 1 along with that can be used along with a suitable repair mortar. So while the repairs themselves contribute to a structure's overall environmental impact, they are much less impactful than a demolition and rebuilding approach that is often required for structures that have been allowed to deteriorate. Demolish and rebuild approach, construction is, or under the demolish and rebuild approach, I should say, construction is more material intensive and creates more waste than a renovation project would. Most environmental impacts occur during the manufacturing process, like the mining and transportation of sand and gravel, which requires energy-intensive processes. And the creation of cement is the most carbon-intensive portion of the concrete process. After the manufacturing and construction processes, there are many benefits to concrete, including durability, low maintenance. They're resilient to floods, fires, and deterioration, and they have a high thermal mass. Ideally, at the end of a building's life, the concrete is ground up to make aggregate for new concrete and can have an added benefit of absorbing CO2 or carbon. However, there are certain instances or certain circumstances when sometimes demolishing and rebuilding are not a bad idea. In cases where the building has so much damage that renovation costs would equal or exceed the cost of rebuilding. If you have to rebuild, you should consider using sustainable practices. It really boils down to proper planning and assessment of a project. The longer these buildings stay in service, the more environmental impacts are diminished over their full life cycle. And our buildings and infrastructure have to be able to withstand both current and future challenges. There was a report done by the U.S. National Trust for Historic Preservation in 2016. And in this report, they found that it takes 10 to 80 years for a new building that is 30% more efficient than an average performing existing building to overcome the negative climate impacts related to the construction process. So reusing an existing building and upgrading it to be as efficient as possible is almost always the best choice, regardless of the building type and climate. To meet the needs of today without compromising the ability of future generations to meet their own needs, we must consider the triple bottom line. For those of you who are unfamiliar with the triple bottom line, it's an impact-focused framework that includes social, environmental, and financial factors as bottom line categories. Consider the effects of repairing and demolishing and rebuilding. What are the potential impacts on the expected economies, the environment, and the quality of life? And while we can build newer and taller and bigger, this approach does not mean that we should if a viable approach exists. So we have to ask ourselves how building new impacts the triple bottom line. And I'll use a bridge as an example here. So maybe it makes more sense financially to build new, but how does building new impact the other two areas that you have here? And again, all of these are rhetorical questions, but a series of questions to keep in mind when you're trying to determine the best path would be something like, is the surrounding environment impacted more by repairing or rebuilding? What about the local community? How would demolishing an existing structure impact the social side? How would demolishing a building impact the local community if, for example, they had to travel further to get to their destination? And then furthermore, how do those changes in traffic patterns impact the environment? Will the carbon footprint of travel increase or decrease? And how does this then impact the local economy if the traffic pattern changes. So lots of things to consider when you're looking at the triple bottom line approach. There are a few steps for repairing concrete that should be considered to minimize its environmental impacts. First, evaluate the existing structure. You want to perform a sustainable repair assessment. Choose the best approach to repair the damaged structure. Specify sustainable materials in repair and the actual repair itself, and then implementing a monitoring and maintenance plan. First, a thorough and logical evaluation of the current condition of concrete in a structure is the first step of any repair or rehabilitation project. When the existing condition of a structure indicates that a major repair is necessary, a comprehensive evaluation of the structure should be conducted to determine the scope of work required. Perform a visual inspection to locate and define areas of distress or deterioration. Review available plans or maintenance records of the building or infrastructure if possible. Using a non-destructive approach, test the concrete's properties such as strength, as well as conditions of the existing structure, such as the conditions of strain, the conditions of stress, without actually damaging the structure to find out what's going on. Only if necessary should you perform destructive testing for more accurate and reliable data. You should identify the type and cause of deterioration. In order to properly repair the structure, it's best to understand what the cause of deterioration was in the first place. And once these steps are complete, the project team should determine if the structure will be repaired or demolished. Assuming the repair is the best approach for the existing structure, it's important the next step be to perform a life cycle assessment. In order to improve the sustainability of concrete structures and repair the overall life cycle, a life cycle assessment, an LCA, or a life cycle cost analysis, LCCA, should be performed to determine the costs impacts as well as environmental impacts. An LCA is a holistic method to determine the environmental impact of a product or processes with systematic set of procedures for compiling and examining the inputs and outputs of materials and energy during the entire life cycle. A life cycle is the interlinked stages of a product or service system. So from the extraction of natural resources to final disposal, which is cradle to grave. The life cycle cost assessment is an analytical method to determine the economic performance of a product or process during the entire life cycle. When the initial cost is taken into account, along with future cash flows incurred throughout the lifespan of the predefined period of analysis. Namely, the best strategy for several alternatives can be chosen due to a comparison of costs over the entire life cycle. There's a wide range of repair methods available, and selecting the appropriate approach for your specific project is essential. The first step is to identify areas that are damaged and areas that can be salvaged. Next, the best approach to repairing the existing structure, and you should also identify the potential future deterioration, contamination that you could have. Select sustainable materials and innovative techniques that extend the service life of a building or infrastructure, and continue to develop the repair and maintenance plan that was started in one of the earlier steps. Implementing the plan using materials that will minimize environmental impacts mainly. There are other sustainable attributes listed here that are impactful and could positively or negatively impact other sustainable areas like circularity, social equity, and health impacts, but these are primarily for environmental impacts. So one of the key aspects of sustainable concrete repair is the use of advanced materials that minimize environmental impact. For instance, the incorporation of recycled content or recycled materials such as fly ash, ground granulated blast furnace slag, recycled aggregates. If you're incorporating these into the repair mixes, you're reducing the demand for raw materials and you're diverting waste from the landfill as well. These are sustainable alternatives that not only contribute to the conservation of natural resources, but they also help reduce the carbon footprint of repair and reinforcement practices. In addition to recycled content, there are sustainable concrete repair and reinforcement criteria that also involve the application of innovative techniques that extend the service life of structures. An example would be advanced corrosion resistant reinforcing materials such as fiber reinforced polymers or FRP, and these can be used to replace traditional steel reinforcements. FRP materials offer superior durability, reduced maintenance needs, and a longer life cycle, thereby promoting sustainability by minimizing the frequency of repairs and the associated environmental impacts. The first step of repair, so now we're actually at the repair part, is to remove any damaged areas. And this may include destructive tests that require the surrounding area that be broken to find any problematic areas that have not been fully exposed yet. Addressing repairs after deterioration has caused damage that greatly increases the cost of mitigation. And investment in preventative maintenance results in shorter, less disruptive interventions that are highly cost effective over the life cycle of a building compared to waiting until it deteriorates. Use innovative techniques and materials that will extend the life of the structures. Sustainability, resiliency, and ongoing maintenance must be an integral part of repairing infrastructure and buildings. Prioritize the implementation of the repair and maintenance plan, and then again, that's to continue to mitigate the deterioration of structures. So the actual monitor and maintenance plan part of the steps would be these protective measures during construction and then the proactive maintenance after can prevent the need for repairs and are ultimately a more sustainable approach. These should be included in the initial cost of construction. Repairs are required whether or not the building or infrastructure was adequately built. Using the repair and maintenance plan to conduct regular inspections of the structure, the building or infrastructure would be ideal, because timely repair of minor defects and the application of protective coatings can significantly extend the lifespan of concrete structures. And ultimately, you're reducing the need for extensive repairs, minimizing disruption to the environment, and reducing the cost throughout the life cycle of the building or infrastructure. Sustainability in concrete repair and reinforcement practices involves the integration of sustainable materials and innovative technologies, as well as proactive maintenance strategies. The longer existing infrastructure or buildings stay in service, the more environmental impacts are diminished over their full life cycle. A comprehensive understanding of existing infrastructure and proactive maintenance is necessary. Maintaining the repair and maintenance plan, and when repairs are required, follow this repair process that you see here. And by embracing these sustainable approaches, the construction industry can mitigate environmental impact and enhance longevity of infrastructure and buildings, and promote a more resilient and sustainable built environment for future generations. And I have one last slide here on the Center of Excellence for Preservation and Service Life Extension, PECS. Was it created to drive awareness, education, there's education tools, and action to preserve and extend the service life of concrete structures to ensure a sustainable built environment. I'm proud to announce that MAPEI supports this PECS initiative. One of our colleagues in Italy was recently appointed a founding board member. And this initiative, fostered by collaboration between many industry organizations, both nationally and internationally, has developed a clear vision and actionable next steps to preserve and extend the service life of concrete structures. Please visit www.peixcoe.org to learn about how you can use sustainability to repair and maintain your existing concrete and masonry building and infrastructure projects, and how you can contribute to this initiative. Thank you all for your time today. Please feel free to reach out with any questions about the presentation, more information about sustainability and how MAPEI products support sustainability, as well as repairing and restoring your existing buildings and infrastructure. Thank you.
Awesome. Excellent presentation. Thank you, Brittany. Like she said, if anyone has any questions, feel free to reach out to the email addresses on the screen and we'll make sure to get an answer over to you. Thank you for joining us today and have a great rest of your day.